We're here on the roof again, and essentially what we're doing today is we're going to size the conductors going into this motor. So how this system works is these plumbing parts right here, these lines coming in, they're going clear across the job site to the cooling towers. That sends cool water through these, and it's going to cool down the air. And then what is going to blow this air throughout the whole entire building? This motor right here. We need to size our disconnects to that motor. Or sorry, our conductors for that motor. So right here's our disconnect that attaches to this bar. Our lines are going to come in right here, line 1, line 2, line 3. Off of this, it's going to go through our overloads. From that symbol right there, you can tell they're heaters. And then to our VFD, our variable frequency drive. This controls the speed of the motor. This little plate right here, if you access that, you can run Cat 6 or Cat 5 to it. And you can remote control this VFD through a backbone with low voltage controllers. Or you can set it manually. And then we can size accordingly for this blower. So let's climb in here. Here is the fan motor. This spins this guy right here, which blows the air through the whole entire building. Here is the nameplate. So if we are sizing our conductors, we're going to go off this 10 horsepower, voltage 230 or 460, amps 24 or 12, and we got 3-phase. And this other stuff, code K, class F, that is important, but not when we're sizing the conductors. Now if you'll notice, there's 2 voltages, 230 or 460, and 2 amperages, 24 or 12. Well, right here it shows that this is able to be tapped 2 different ways, high voltage or low voltage. That nameplate on that door, which I'll show you in just a sec, says it's tapped at high voltage. So we're going to come and read the high voltage, 460, and that's 12 amps, 10 horsepower, 3-phase. Now I believe it says, yeah, usable at 208 volts. So there's also tap options for that. And then we can take those values into the classroom and size our conductors. On this nameplate right here, full load amperage 12, so we automatically know, line that up with the 460. That's what we're using. Max circuit ampacity is 15, max overcurrent protection 27, so we just round that up to 30 for the size up rule. But for sizing our conductors, we're going to take that nameplate and go in the code book and figure out exactly what we need. Alright guys, now we're going to be sizing the motor's conductors. The ground fault short circuit protection, so GFCI/short circuit. The overloads. And what else am I missing? Yeah, I think that's about it. So, here's a little trick that I use to remember what is what. So right here is our nameplate that we had on the motor. Going from this, we just have to remember that this is the full load amps, the FLA. I remember that by this. FLA is the name plate, and it's the full load amps. So that amperage is found right here. What do you use the FLA for? You use overloads, or use the overload, or sorry, the FLA, the nameplate, to size your overloads. That's essentially it for the full load amperage. Now, if we want to use the FLC, this is your NEC, your code book. Code book, or your NEC. I don't know, that's how I remember it. Some of my students, they say code book, or I remember NEC FLC. NEC FLC. And for this reference, you're going to size pretty much everything else. Your conductors, your short circuit, / ground fault, and your disconnects. That's right. Sorry, disconnects. And your breakers. / fuses or whatever. Alright, so let's start with the conductors. Before we get into that, we have to know FLC, NEC, the code book. Well, where exactly are we looking in the code book? We are going to look in table. FLC is table 430.248 and 249 and 250. Those three are going to be your 3 pages of reference when dealing with the code book. Now remember, 430.6A1 is the reference to the FLC. So let's flip to that real quick. So in 430.6A1, I don't know if you can tell, but it's essentially saying when you need to use FLC and when you need to use FLA. So what we're going to do, on page 332 in my year 2020 code book, is the horsepower ratings of each of the motors. We're going to take this number right here, and we're going to plug it into the NEC. So we have 10 horsepower. Now remember, the voltage and the amps were different depending on what it was tapped for. So, I remember correctly, it was tapped for the higher voltage. So we're going to use this voltage. Oops. We're going to use this voltage right here. And we are going to use this amperage. Now, 10 horsepower, doesn't matter to the voltage, that's what the horsepower is rated at. Let's go in the code book and see what that's rated at. So if you'll look right here, it's 3-phase. Let's come into our code book. 430.250 full load current, the FLC. 3-phase. Now it was 10 horsepower. 10 horsepower. And I believe the voltage was 460. 460, so 14 amps. Okay, so 14 amps found in our NEC. The full load current in the NEC, the code book, it was 14 amps. Okay, so we have 14 amps. Now, since we're sizing conductors, we need to remember conductors at 125% of the FLC. So what we're going to do is 14 amps, so 14 times 1.25. Let me get my calculator here. $17.5. $17.5 amps. Now this 125% rule is found in 430.22 of your NEC, and that says, for a single motor, conductors that supply a single motor used in a continuous duty application, since it's a single motor, that's just what we're going to use to size it, shall be not less than 125% of the full load current rating. Full load current, FLC, NEC, codebook. So 430.22 says 125% of the number that we found in the NEC. We had 10 horsepower. We went in, and in 430.249, we found that 10 horsepower on a 3-phase 460 volt motor was 14 amps times 125% equals 17.5. Now, let's go into table 310.16, ampacities of conductors. If you see here, I have below 100 amps and above 100 amps. This is just for motor conductor sizing. You shouldn't really write in your code book like that. I just have a little note here for myself. It's below 100 amps, 17.5. So we're going to size up to 20. That's 12s. So we can use 12 wire on this motor. Okay, so we're going to use, oops, let me get a different marker here. 12, dang it. Okay, so we're going to use 12 AWG. Shit. Okay, so we're going to use 12 AWG for that motor that we saw on the roof. If there was multiple motors being run, which I believe on the other one right across from it, there is, what we would do is 125% of the FLC of the largest motor plus the sum of the rest. So if there was, for example, one at 10 horsepower, 460 volts, and then one at 8 horsepower, 460 volts, we just have to go off what the NEC says. This one could be rated at a higher horsepower, but it doesn't necessarily mean that it's higher amperage. So we have to look in the NEC. We can't use the nameplate. We just get our horsepower from there. Say we had one that was 12 horsepower, 460 volts. That one's going to be higher amperage. And we're going to do 125% of the 12 horsepower one off the NEC. So let's go into this. 3-phase, table 430.250, 12 horsepower. Let's say it's 15 horsepower. How about that? 15 horsepower, 460 volts, 21. So essentially, what we would then do is, if we had horsepower of 15, 460 volts, we would, what did we get? 15, 21 amps FLC. And then that one was 14 amps. 14 amps FLC. We would go 21 times 1.25, and that is 21 times 1.25, 26.25, 26.25 plus the sum of the rest, 14 amps, 14.00 plus 40.25. And that is what we would size our conductors on if both of these were running off the same feeders. So let's come over here. Let's go into our ampacity tables. So we're still below 100 amps, 40.25, below 100 amps. Let's come down here to 40. Ooh, just hitting the cutoff, 40.25. We're going to have to size up. We're going to have to use 6 AWG for this one. Alright, so that is how you size the conductors for a motor, and that was a real life example of us doing it. I think in the field we're actually going to pull 10 wire just to be safe and just to account for voltage drop, but we could get away with 12 wire. The panel is, I think, like 40 feet from it. It goes downstairs. So just a note, next time we're going to be going over some GFI short circuit, maybe some overloads, use the nameplate for something, and maybe we'll size some disconnects. But other than that, that's how you size the conductors and the feeder conductors for a motor. Thanks, guys.